Alright, problem number 6. Want to find the equation of the tangent line at the given point. So we need to take the derivative of this conic section. If you choose to, recognize that this is an ellipse because x and y are both squared and they're both positive. But we actually don't really care because the derivative is going to work the same way no matter what. So let's take the derivative term by term. The derivative of 4y squared, derivative of y with respect to x, is going to be 8y dy dx, plus the derivative of 40y is going to be 40 dy dx. Remember, anytime you take the derivative of y with respect to the derivative of x, you need to add that dy dx when you do it to a y term. Plus 9x squared becomes 18x via the power rule, minus 54 is what we get when we take the derivative of x with respect, oh, my dog's barking, derivative with respect to x of negative 54x, sorry, blabbering, and the derivative of any constant term such as 37 is 0, and the derivative of 0 is also 0. So now we want to isolate the dy dx's. So move the 18x minus 54 to the right by subtracting 18x and adding 54. So we'll get 8y dy dx plus 40 dy dx equals negative 18x plus 54. Now notice on the left we've got a dy dx in both terms, so we can factor that out. Dy dx equals 8y plus 40 equals negative 18x plus 54. So divide by 8y plus 40 on both sides to get dy dx, derivative of y with respect to the derivative of x, equals negative 18x plus 54 over 8y plus 40, which, if we factor the numerator and the denominator, we can simplify it, pull out a negative 18, and you're left with x minus something. What is that something? I don't know. 54 divided by 9 is 6, and 6 divided by 2 is 3, so we're going to get x minus 3. You can check me on that, but I think it works. Also, yeah, check it. 3 times 8 is 24, and 3 times 10 is 30, so we get our 54. Sweet! Math is awesome. Over, factor out that 8, we're going to get y plus 5, which we can continue to simplify. Pull out a 2 from each of those to get negative 9 times x minus 3 over 4 times y plus 5. And that's as simplified as you're going to get it. And now we want to check that point 3 comma negative 11. So we're going to get negative 9 times 3 minus 3. Alright, so I don't remember where I left that thought off, but I just realized that the point I gave you was really kind of boring, because notice the x value was 3, and so we get that quantity 3 minus 3 there, and so this slope is just going to be 0. So that's really pretty boring, but if I gave you a different point, it'd be the same deal. You'd plug it in, you'd find your dy dx, which is your slope of the tangent line at that point, and then you would substitute into y equals mx plus b. We can go ahead and keep doing it if we want, just for she's and g's. So y was negative 11 plus 5, and we're going to get that 0 again. But the whole point of this is the y value we were told is negative 11 equals our slope, which is 0, times x, which is 3, plus b, So I know that my y-intercept is negative 11, which of course is obvious because my equation is just y equals negative 11 because I was at one of my vertices. That's why my slope is 0. So that's kind of boring. But again, if it was a different point, just plug in the x value, plug in the y value, go from there, get your slope, plug in, solve for b, bada boom, bada bing, you are done, my friend.